Click the bell icon to get latest videos from Ekeeda.
Hello friends, so far we have seen various forms in which we can represent regular languages: finite automata, regular grammar, regular expression. In the last video, we discussed about closure properties. In this video and onwards, we will be discussing on closure properties of regular languages. Let us start with the first one. In this video, we will be proving that regular languages are closed under union operation. In this video, I will be presenting the idea for regular languages in all the three representations, that is, in a finite automata, in a regular expression, and in a regular grammar. In the following videos, we will be continuing with any one of the form which is easier to express for the given statement. Let us start with the first one. The question says that show that regular languages are closed under union operation. Let us take two example languages. Let L1 and L2 be two regular languages. Let M1 and M2 be the machines which accept L1 and L2 respectively. Now, let us try to define the machines M1 and M2. Now, let us try to define a machine which is a union of both M1 and M2. What will Q contain? It will contain the set of all states which are there in both Q1 as well as Q2. We can say Q is the Cartesian product of both Q1 and Q2. Sigma is the alphabet set which is common to both machine 1 and machine 2. The transition function delta for M will contain both states from Q1 as well as Q2 as the input state. Similarly, it will have states from Q1 and Q2 as the output state. The initial state for the machine Q0 will be a combination of Q0 from machine 1 as well as Q0 from machine 2. The final state is the important one. The final state will be having the union. That means the final state will be the final state F contains a set of all states from Q1 and Q2 in which at least one from Q1 or Q2 is a final state. In the definition, I have stated as that it is a set of all state QP, QK where at least QK is a final state or QP is a final state. Hence, this FA will accept the set of all strings in which either one of the machine is going to a final state. That means it is accepting the language L1 union L2. If you're able to design a DFA for the given language, that means the given language is regular. Now, using this concept, we can say that as we have designed a DFA to accept the language L1 union L2, L1 union L2 has to be a regular language, which means that regular languages are closed under union operation. Now let us see the second representation, that is using a regular expression. Let R1 and R2 be the regular expressions representing language L1 and L2. We see that the regular expression R1 plus R2 represent the language L1 union L2. As we are able to design a regular expression for the language L1 union L2, we can say that the language L1 union L2 is a regular language, which means that regular languages are closed under union operation. So we have proven using both automata as well as regular expression. Let us say G1 and G2 are represented in right linear method. Let us say S1 is the start symbol for G1 and S2 is the start symbol for G2 respectively. You can see that the grammar which is written now is a representation of a grammar which is right linear in form. provided S1 and S2 are following right linear structure. In this case, this grammar is also regular. Now, in this way, we have proven that regular languages are closed under union in all the three methods, that is, using a finite state machine, using regular expression, as well as using regular grammar. Now onwards, we will be using any one of the representation which is suitable for the given operation. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.